Hello there, everybody. Welcome back. This is going to be lesson 2 in Unit 2, and today we're going to go over the parts of the periodic table. So in the last video, we covered the history of the periodic table, why it's organized the way it is. So that leads to a question. How is the modern periodic table organized? So the modern periodic table is organized by atomic number, and remember that is the same as the number of protons. One of the guys that was studying this was thinking, oh, maybe we can organize by mass, and that worked for a little bit, but remember, isotopes exist. So atomic numbers is how the periodic table is organized. So on today's video, we're going to talk about the different parts of the periodic table. We're going to color code this, talk about the differences between the different groups, and how to classify elements. So we mentioned this in the last video, but the periodic table, again, you can obviously see is made up of different rows and different columns. So the horizontal rows are what we call periods. So again, I like to think of, a sentence, or anything that's reading in this video, is horizontal and ends in a period. So these horizontal rows that look kind of like how you'd write a sentence is horizontal would end in a period. Now, these rows or these periods also tell you the number of energy levels. So this first level would have 1 energy level. This second row would have 2 energy levels, 3, 4, and all the way down. So how many energy levels would period 5 have? Okay, so period 5, you go down, has 5 energy shells. And you can even see that on your electron configuration. You'll see 5 numbers, number dash number dash number dash number. Whereas, if you're on the second shell, you only see 2 of those numbers. And again, the number of valence electrons, or the outermost electrons, valence electrons are super important. So the outermost electrons increases from right to left. So things and we'll talk about it as we move on, but forgetting this middle section, here we start with 1 valence electron. We have 2, 3, 4, 5, 6, 7, 8 valence electrons. So we'll talk more about that on the next slide. And these properties change as you go across. So just because you're in the same period or that same row doesn't mean you're going to behave the same way. So properties change. So the next are these vertical columns, and we call those groups or families. Most of the time, you'll probably see them as groups. So this would be group 1, group 2, all the way through, group 18, 17, and so on. So most of these electrons, and again, minus this middle section because it gets a little funky in there, have the same number of valence electrons. So anything in group 1 would have 1 valence electron. Anything in group 2 would have 2 valence electrons. Forget the middle section. Group 13 things have 3 valence electrons, and so on. So how many valence electrons do you think something in group 15 would have? You should say 15 valence, not 15, 5 valence electrons. So again, you can tell that based on the periodic table, the electron configuration. And then because they have the same number of valence electrons, they have similar chemical properties. And when we get into bonding, this will make more sense. But things with 1 valence electron tend to act similarly. Things with 2 valence electrons, things tend to act similarly. So if they are in the same group or that same column, they have similar chemical properties. This is a super important one. Moving forward, we have 3 classes of elements: metals, nonmetals, and metalloids. So here would be a good time to pause this and outline the different sections on your actual periodic table. So we're going to color code this, and I highly recommend that you do this on your own as well. So here's this metalloid staircase in orange. Anything to the left of it is a metal. So anything in blue is a metal. Anything to the right of that staircase is a nonmetal. Okay, so here is how I color code the periodic table. I love using colors and rainbows, so this is what makes me happy. So if you want to use different colors, whatever makes you happy, that's fine, but as long as you break it down into these different sections. So again, now would be a great time to pause this and color code your own periodic table. So again, everything that light blue staircase is that metalloids. Everything to the left of it is a metal. Now, even though these aren't colored in, they're still metals. We just don't really care about them that much. Again, anything to the right of that staircase is a non-metal. And just because these aren't colored doesn't mean anything. We just aren't going to color them. One thing to kind of point out, hydrogen, although it's on the left side of the staircase, is a non-metal. So that's a trick question they like to ask. So anything to the left of the staircase, except for hydrogen, is a non-metal. Okay, so going into this, there are a few different types of metals. We have the alkali metals, alkali earth metals, transition metals, and the inner transition metals. So we're going to go ahead and talk about each of these in more detail. So first is this red column, and notice how H is not colored. These are your alkali metals. So group 1, that first column. These are the most active metals, so and they react vigorously, so very aggressively with water to produce this hydrogen gas. So remember, sodium is in that column. So when you put sodium into, a glass of water, there's water, it explodes. These things are generally pretty shiny, and you can actually cut them with a knife. So you might not think of a metal as being soft and being able to cut with a knife, but you actually can. And then as you go down the group, so the farther and farther you go down group 1, the more and more reactive you get. So, question, if you're looking at your periodic table, what element is the most reactive? Okay. So group 1 is LiNaK, Rb, Cs, and Fr. So the lower you go, the more reactive you get. So francium, Fr, would be the most reactive metal. Okay. Next is group 2, this orange. And these are your alkali earth metals. So again, these are anything in group 2, and these are the second most active metals. So group 1 is the most active, and then group 2 is the second most active. Okay, next are these transition metals, these yellow and green sections. So these transition metals, they're groups 3 through 12, so that middle section. Just about all of them are these hard solids, except for mercury, which is a liquid. And the symbol for mercury is Hg. So that doesn't really match up with its name. But mercury is a liquid. But besides that, they're all solids. They have very, very, very high melting points. And when we get to bonding, we'll talk about why. Cool fun fact about these, and kind of important as well, things with these transition metals form these colored compounds. So if you have like a copper sulfate solution, that is a blue liquid, and it's blue because of that copper. Copper is Cu, that is in the transition metal section. Okay. Moving on to the light blue staircase. These are your metalloids. So on your periodic table, you'll see a kind of bold line. So things touching that line are your metalloids, minus, I think, aluminum technically has a bold line on it, but isn't a metalloid. So this is a great definition question that pops up all the time. Metalloids have properties that are similar to metals and properties that are similar to nonmetals. So they're kind of this in between. Sometimes they act like a metal in certain cases, other times they act like a metal in other non-metals in other cases. So they could be shiny, they could be dull, they could be semiconductors, all these different we'll talk about these properties shortly, but they kind of have a mix of those two properties. So the metalloids you need to know are boron B, silicon Si, germanium Ge, arsenic As, antimony Sb, tellurium Te, and polonium. Okay. Now let's talk about group 17. Group 17 are your halogens. So if you were to look up the etymology or the word history of the word halogens, halos Halos comes from Greek meaning salt. And so we're talking about these salts. A lot of these salts that you know and love come from group 17. So if you think of, NaCl, that's part of that salt. So group 17 things most of the time are used to form these salts. So group 17 has 7 valence electrons. These are the most active nonmetals. So they're super, super, super reactive for nonmetals speaking. The chemical reactivity decreases as you go down the group. So F, fluorine, would be the most active, or most reactive, we could say. And then AT would be the least reactive. And so this deals a lot with the phases of matter that they're in. Gases are the most reactive, solids are the least reactive. Okay. And then one of the other points to say is that they're all diatomic. Remember, that's 2 of the same atoms connected together. So you'll see, F and F, Cl and Cl. They always travel with their identical twin. Okay, on to noble gases. Noble gases are group 18. These are these colorless gases. And generally, they're very, very stable on their own, or we can even call them inert. When we talk about bonding, we talk about the importance of these valence shells, these valence electrons. And so every atom wants to have 8 valence electrons in their outermost shell, in that valence shell. And a lot of them don't. So what they have to do is they have to bond. But noble gases already have that full valence shell. They have 8 electrons, but helium has 2 valence electrons. But if you're looking at helium itself, it only has that valence shell, that it only has 1 shell and it's all the way full. So these noble gases are literally like the kings and queens. They're like, I'm too good for you. I don't need to deal with all these little peasant elements. They don't need to bond. They have everything they need. And so we can say they are monoatomic because they're unbonded single atoms. Okay. So just going over a few different properties, something that, or the definition of metallic character, is defined as to how easily or readily an atom can lose an electron. So again, when we talk about bonding, metals tend to lose electrons and nonmetals will gain them, and we'll talk about why later on. So metallic characteristics decrease from left to right. So this is your periodic table. And if we're going left to right, metallic properties, MP, decrease. And that makes sense because if you're going to the section of nonmetals, you're going to act less and less and less like a metal because you're not a metal. And as you go down, the metallic character increases. Okay. So just a few properties of metals. They're solid at room temperature. They're malleable, meaning you can kind of bend them. They're ductile, which again means you can kind of put them and stretch them into wires. They're luster, that means they are shiny. And they are great conductors of heat and electricity. Non-metals, on the other hand, most of them are gases. Not all of them, but most of them. They tend to be brittle. So if you try to bend it, it will snap or turn to powder, kind of like this sulfur. They're pretty much dull. They're, again, the complete opposite of these metals. And the picture's cutting it off, but these are poor conductors of heat and electricity. So that's why different things that you think, if you put like a pencil, which is made of just like carbon and graphite, in a hot cup of water, pencil doesn't really get that warm. But if you put a metal spoon in that hot cup of coffee, the spoon is metal, the spoon becomes a lot hotter because it is a better conductor. Okay, and then properties of these metalloids. Again, these are these intermediates between the metals and the nonmetals. So sometimes sometimes they act like metals, some parts of it they act like nonmetals. It's that kind of mix between. So a lot of these are shiny, like a metal would be, but they also have these other properties and they kind of behave like nonmetals. So they look like metals, but they act like nonmetals. So that's pretty much it for this video. It was a long one, but we covered a lot of information. So next video we will cover periodic trends, so the different patterns that appear on the periodic table, some of which include atomic radius, ionic radius, electronegativity, ionization energy, and metallic character. Bye.